Hi everyone, I'm going to be walking you through the equivalent resistance lab. So first things first, you want to get all of your materials. You need a LabQuest, you need a current and voltage sensor, you need a cup full of resistors, some of which have been soldered together, as you can see here. You want a 6-volt battery. You may want to use a switch. You don't have to though. And you also need 1 red alligator clip and 3 black ones. But if you're not using the switch, you don't need 3, you only need 2. So first, you want to plug your current sensor and your voltage sensor, current into channel 1 of your LabQuest, and voltage sensor into channel 2 of your LabQuest. Once they're all plugged in, you want to come up to your sensors and make sure that they are zeroed out. So sensor, 0, all sensors. And they will still fluctuate a little bit. You might see 0.001, negative 0.001. That's fine, but they should start at about 0. For wiring your circuit, you want to start at the positive end of your battery with a red alligator clip. And with that same clip, put 1 resistor by itself, clip that into the alligator clip. Take your voltage sensor, your voltmeter, and take the red clip on that and put it on the same side of the resistor as the red alligator clip. Then take the black black alligator clip from the sensor and attach it to the other side of the resistor, as well as one of your alligator clips that's not attached to the voltmeter. So on your resistor, you should have 2 red and 2 black on opposite sides of the resistor itself. Let me see if I can get a little bit closer here, just so that you get a better picture of what's going on there. From there, you follow your black alligator clip over to the positive end of the current sensor, and then you take another alligator clip, go from the negative end of the sensor over to your switch. If you're not using your switch, you can go directly to the negative terminal on the battery. But if you are using a switch, then it goes one side of the switch here, and then take your other clip from the other side of the switch to the negative terminal of the battery. So when I throw the switch, you'll notice that there is a change in both the potential and the current on the LabQuest. So you'll want to take data from both of those, put that into your table here for resistor 1. And when I let go, it goes back to 0. If you are not using the switch and you're connecting directly to the battery, please make sure that when you are not taking data, there is a break somewhere in your system, in your circuit. Because if you don't have this released, you'll start to build up heat in your resistor, and that will either damage the resistor or it will take your measurements and put them a little out of whack. So make sure that there's a break somewhere in the circuit if you're not actively taking data. When you're done taking data for the first one, you're going to remove that single resistor and in its place put a double resistor, right? So these two have been soldered together in series, and you're going to attach it the same way you would with a single one. I've got 2 red on one side, 2 black on the other side. You want them on outside of both of the resistors. You throw your switch, you take the data for that one as well, and that goes in 2 resistors in series, 2 resistor 1s in series. And then again, same thing, but now this time with 3 resistors soldered together in series. When you're all done with that, right, you've got all of your data for your series trials. You're going to go into your cup and you're going to take 2 single resistors and put them in parallel with each other. So clip them both in on your right into your circuit, and that will go into table 2 for 2 resistors in parallel, right? Obviously, we can't have just 1 resistor in parallel, so this first row gets copied down into the second table. And then once you have the 2 resistors in parallel, you go to 3 resistors in parallel, and again that goes into table 2 for resistor 1. Once you're done with all of the data for 1 resistor, you take all of those resistors, put them back in a cup, and you grab a different cup full of resistors. All right, these should have a different color code on them. So these ones are gray, red, black, gold. You want to find one that has different color codes. So this one is the resistor 1, resistor 2, and resistor 3. Those are all different cups of resistors. So again, you have 1 in series, 2 in series, and then 3 in series, all from the same cup. After that, you take 2 in parallel, and then 3 in parallel, still from the same cup. When you're done with that, you take a different cup and do it the same way. 1 in series, 2 in series, 3 in series, and then 2 in parallel and 3 in parallel. Make sure you get the color codes because you'll need that for your data taking. There are also some analysis questions on this page here.